Launched in 1977, Voyager 1 predates most people alive today. And yet, it still flies. A tiny spacecraft, now over 24 billion kilometers from Earth, more than 160 times the Earth-Sun distance. Alone, but not silent. Its faint signal, taking nearly a day to reach us, still whispers discoveries that continue to shock scientists. This is the story of Voyager 1, humanity's most distant outpost. From its first look back at Earth, to its dramatic planetary encounters, to its extraordinary discoveries in the space between stars. You've landed on Astrovault. My name is John, and if deep space missions like Voyager fascinate you, consider subscribing. We explore the cosmos, one mission at a time. Voyager 1 was one of a pair, twin spacecraft launched just weeks apart. The first, Voyager 2, launched on August 20th, 1977. Voyager 1 followed on September 5th. Both were designed to take advantage of a rare planetary alignment, a cosmic window that opens only once every 176 years. The timing allowed them to use gravitational assists from the planets to slingshot forward, multiplying speed without burning massive fuel. This technique turned a 5-year mission into an interplanetary odyssey. Voyager 1 was sent on a faster trajectory to reach Jupiter and Saturn first, then head out of the planetary plane toward interstellar space. Voyager 2 took a slower route, one that would allow it to visit all 4 outer planets: Jupiter, Saturn, Uranus, and Neptune, completing the full grand tour. While Voyager 2 began its longer tour of the outer planets, Voyager 1 moved ahead and made history early. Its first milestone? A photograph of Earth and the Moon in a single frame. The first ever captured from space beyond Earth orbit. Yes, it's grainy, low resolution, faint, but it's historic. The first time humanity saw both worlds together, from beyond. Continuing its journey through the solar system, Voyager 1 arrived at Jupiter on March 5th, 1979, 547 days after launch, and revealed a system far more violent and more complex than imagined. Its cameras showed a planet in constant turmoil. Massive storm systems churned in its banded atmosphere, hurricanes larger than Earth, moving faster than any jet stream. At the center of this chaos sat the Great Red Spot, a swirling anticyclone, wide enough to swallow 2 Earths and at least 300 years old. It wasn't just a storm, it was a planetary landmark. Then came the first surprise. Jupiter, thought to be a world of clouds and moons, had rings, faint, dusty, invisible from Earth. Voyager caught them in scattered light, a discovery that reshaped how we think about giant planets. Saturn didn't own the rings. Not anymore. But what truly redefined Jupiter was what couldn't be seen with a camera: its magnetic field. Voyager detected a magnetosphere 10 times stronger than Earth's. It stretched for millions of kilometers, forming a giant radiation trap filled with charged particles. This wasn't just a planetary magnetic field. It was a fortress, a magnetic environment capable of reshaping orbits, frying electronics, and creating auroras that span entire hemispheres. And orbiting inside this fortress was a system of moons so diverse, so scientifically rich, that it could be studied for decades and still hold unanswered questions. Voyager imaged 2 of the largest, Ganymede and Callisto. Ganymede, larger than Mercury, showed surface features no one expected. Grooves, ridges, bright terrain intersected by darker bands. It wasn't dead, it was changing. Its icy crust had been pushed, pulled, and reshaped, signs of tectonic activity on a frozen world. Callisto told a different story, older, quiet, covered in impact scars from billions of years. a relic from the early solar system, largely untouched. Where Ganymede whispered motion, Callisto preserved memory. But the real shock was Io. Days after the flyby, while reviewing images, a navigation engineer named Linda Morabito spotted something strange, a curved anomaly rising above the moon's edge. It wasn't an artifact. It was a volcanic plume, 300 kilometers high. A geyser of sulfur erupting from the surface, caught mid-eruption. This was the first active volcano ever seen beyond Earth. And it wasn't a one-off. Io was covered in them. Bright plains, stained by sulfur. Pits still warm. Lava lakes flickering in infrared. This wasn't a geologically dead rock. It was alive. Driven by tidal forces from Jupiter's immense gravity, Io's interior was flexed and compressed like a rubber ball, generating internal heat. Geological activity was no longer Earth's private domain. Then came Europa, quieter, subtler, but maybe even more important. Voyager's images showed a smooth surface, crisscrossed with dark lines, not cracks, fractures. Beneath that frozen shell, scientists began to suspect something extraordinary. A global ocean of liquid water, kept warm by tidal flexing, hidden beneath kilometers of ice. If Earth's oceans could harbor life, why not Europa's? That question never went away. In fact, it became a mission. NASA launched the Europa Clipper on October 14, 2024, the most expensive and sophisticated planetary science mission in its history, to determine if Europa could support life today. Not in theory, not in the past. Voyager didn't just explore, it redefined the search for life itself. On November 12, 1980, Voyager 1 arrived at Saturn, the solar system's crown jewel. Seen through Voyager's cameras, the rings weren't smooth. They were complex, thousands of ringlets, tightly packed and sharply defined, some only a kilometer wide. What looked like a single structure from Earth was actually a highly organized system of icy particles in motion. Within that system, Voyager found moonlets, tiny embedded satellites, previously undetectable. They carved edges, cleared gaps, and created waves through the rings. Then came the spokes, dark radial streaks that would appear and disappear without warning. Voyager captured them repeatedly. Their origin is still debated. Possibly magnetic interactions, possibly charged dust suspended above the rings. Saturn's rings weren't just beautiful. They were active, dynamic, and more complex than expected. But Voyager wasn't just there for the rings. Its most important target was Titan, Saturn's largest moon, bigger than Mercury, covered in haze. A major unknown. Voyager's instruments revealed a dense atmosphere, thicker than Earth's, made mostly of nitrogen and methane. It also detected organic compounds like ethane and acetylene, the chemical building blocks that can lead to more complex molecules. This was the first time we'd seen an atmosphere like this outside Earth. Years later, we came back. In 2005, the European Space Agency's Huygens probe, delivered by NASA's Cassini spacecraft, landed on Titan. It remains the only landing ever made in the outer solar system. The farthest from Earth any spacecraft has touched down. Titan wasn't just interesting. It was important enough to land on. Voyager made that discovery possible. Then, there was Enceladus, a small, icy moon only 500 kilometers across. Voyager showed a surface that was unusually bright and had far fewer impact craters than expected. It was a quiet clue, easily overlooked at the time. More than 2 decades later, the Cassini spacecraft revealed what Voyager had hinted at. Geysers of water ice erupting from Enceladus's south pole. Vapor, salt, and organic material, signs of an internal ocean beneath the ice. Even the smallest moons held secrets. Voyager had started rewriting the textbook. With its final planetary encounter complete, Voyager 1 veered northward, leaving the ecliptic plane and the outer planets behind. Nearly a decade later, on February 14, 1990, it turned its camera back toward home. From a distance of 6 billion kilometers, or 3.7 billion miles, and positioned 32 degrees above the ecliptic, Voyager captured one final image of Earth. At the request of Carl Sagan, it took a portrait of the solar system, and in one of those frames was our planet. A pale blue dot, a single pixel, suspended in darkness. A world reduced by distance to almost nothing, and yet everything we've ever known. Then, Voyager continued on, into silence. It was now beyond the reach of any planet. Its instruments, originally designed to survive intense planetary radiation, were pushed into new territory, the cold, sparse environment between stars. Power became the mission's greatest constraint. To stay alive, engineers began shutting down subsystems, heaters, instruments, computers, one by one. Every watt was budgeted. Today, the spacecraft runs on less electricity than a household light bulb, and it still functions. In 2017, engineers pulled off something remarkable. They reactivated a set of backup thrusters that hadn't been used in 37 years. With perfect precision, Voyager responded, course corrected, and kept going. Built with 1970s technology, flying blind, powered by atoms and grit, and still speaking to us across the void. Voyager 1 was never designed for this. Its primary mission was expected to last 5 years. By the time it neared the edge of the solar system, it had been flying for over a quarter of a century. Its next objective was unprecedented, to reach the very boundary of the sun's influence. The sun emits a constant stream of charged particles, the solar wind, that flows outward in all directions. That wind creates a vast bubble around the solar system, called the Heliosphere. And Voyager 1 was sent to find its edge. In 2004, it crossed the termination shock, the point where the solar wind slows from supersonic to subsonic speeds. Beyond that point lay the Helios Heath, a turbulent buffer zone filled with compressed particles and tangled magnetic fields. Voyager would spend 8 more years there, navigating a region no spacecraft had ever entered. Then, on August 25, 2012, something changed. Voyager's instruments recorded a sudden drop in solar wind particles. At the same time, high-energy cosmic rays from interstellar space surged. The local magnetic field shifted direction, and plasma density, inferred from oscillations in radio signals, spiked dramatically. Voyager had crossed into the realm between stars. No other human creation had gone this far. It could even hear the plasma. Not metaphorically, literally. Voyager's instruments detected oscillations in the density of interstellar plasma, which scientists converted into sound. And space sang back. Its data continues to reshape how we understand the boundary between our solar system and the rest of the galaxy. How the sun's influence fades, and where interstellar space truly begins. By the time Voyager 1 entered interstellar space, it had long outlived its original mission. It was built for a 5-year planetary tour. Instead, it kept going, adapting, transmitting, discovering for decades. And it wasn't alone. Voyager 2, its twin, completed the grand tour, becoming the first and only spacecraft to visit Uranus and Neptune. Its data transformed our understanding of the outer solar system, revealing ring systems, magnetic fields, and moons no one had seen before. But it was Voyager 1 that broke the final boundary. the first to leave the sun's domain, the first to enter the space between stars. On board each is a message, a time capsule meant not for us, but for whoever might someday find them. Sealed in a protective case is the Golden Record, a collection of sounds, music, and greetings from Earth. 55 languages, images of life, the sound of rain, a kiss, footsteps, a heartbeat, a snapshot of who we were and what we hoped someone might one day understand. Soon, Voyager 1's instruments will go dark. Bit by bit, power will fade. The signal will stop. But the spacecraft will continue, on a silent path around the galaxy, moving at 17 kilometers per second. Unreachable, indestructible, alone. Voyager 1 showed us volcanoes on moons, oceans beneath ice, invisible fields and interstellar winds. It proved that space isn't empty. It's active, structured, and alive with motion. It reminded us that discovery doesn't stop when the cameras shut down. It showed that our reach exceeds our grasp, and that sometimes to find something truly new, we have to keep going. Voyager's incredible story is just the beginning. This video marks the start of a special 5-part Astrovault mini-series, where we journey alongside humanity's greatest robotic explorers. Join us next time as we follow Galileo, the first spacecraft to orbit Jupiter and the only one to send a probe into its immense atmosphere. A mission that revealed a system of moons more dynamic, more volcanic, and more mysterious than we ever imagined.